Hello students, today we are going to learn to find the rank of a matrix using normal form. For that, let us consider a matrix A is given to us whose order is m cross n. Now what we will do, we will write this matrix A as AIA where I is an identity matrix where I is a identity matrix of order m cross n, m cross m, and the second one, this one, which is post multiplied with a, this I is identity matrix of order n cross n. Now the question is going to arise in your mind that why we are saying that this is of order m and the second one is of order n. For that, let us look at a simple rule which is for matrix multiplication. If we have two matrices A and B and we want to multiply them, then we know there is a condition which must be satisfied so that this multiplication is defined, which says that number of columns of A should be same as number of rows of B. मीन्स अगर हमें दो मैट्रिसेस ए और बी को मल्टीप्लाई करना है तो उसके लिए हमारे पास क्या कंडीशन होनी चाहिए दैट जो ए के कॉलम्स हैं और बी की रोज हैं उनका काउंट क्या होना चाहिए, सेम होना चाहिए. नाउ as you can see here, the matrix A is of order m cross n. First I am pre-multiplying this matrix A with the identity matrix because we know when we multiply any matrix with the identity matrix the answer still remains the same. Now matrix A has order m cross n, and if we want to multiply I with A, then columns of I and rows of A should be equal. Now how many rows are there? M rows. It means the order of this matrix should be m cross m. Similarly, once we are multiplying A with the post multiplying A with the identity matrix again, now the number of rows in A are m, number of columns are n, and we want that number of columns of A should be same as number of rows in the second matrix, that is it should be of order n cross n. I hope it's clear to everyone. Where that is, when we are writing A as which is of order m cross n as IAI, then the identity matrix which is pre-multiplied with A is going to be of order m, and the identity matrix which is post multiplied with A is going to be of order n cross n. Now after that, once we have written the matrix A in the form of IAI, in the next step what we will do in the working procedure, we will apply elementary row operations on this matrix A which is written on left hand side and apply the same operation on the identity matrix which was of order m cross m, or we can say the first identity matrix. And similarly we will apply the column operation on the matrix A which is written on left hand side, and then we will apply the same operation on the second identity matrix I n cross n. And we have to apply the operations in such a way so that our left hand side matrix A reduces to a similar form IR 0 0 and 0, where IR is identity matrix of order R. And now the first identity matrix I which was mentioned here, this will be also reduced when we apply the some row operations on this matrix I. Then let's say this is changed to a new matrix P and the other one is reduced to a new matrix Q. So the resultant is our left hand side matrix is now reduced to IR 0 0 and 0, which is further equals to PAQ. This form which is such generated is known as नॉर्मल फॉर्म ऑफ ए. ये जो हमने अभी नई ट्रांसफॉर्म फॉर्म बनाई है ए मैट्रिक्स को हमने इस आई आर 0 0 की फॉर्म में कन्वर्ट कर दिया और आइडेंटिटी मैट्रिक्स को पी और क्यू की फॉर्म में चेंज कर दिया. ये जो हमने फॉर्म बनाई है इस फॉर्म को हम क्या बोलते हैं, नॉर्मल फॉर्म ऑफ ए. नाउ लेट्स समराइज एवरीथिंग. Consider matrix A whose order was m cross n. Then what we will do, we will reduce this matrix to the normal form, this one, by using elementary row transformation and column transformations. Then we can say the result one which is achieved here is that corresponding to every matrix A, there exist invertible matrices P and Q such that the A can be transformed into normal form, and this R, which was the order of regenerated identity matrix, this is known as rank of matrix A. We can say this R gives us rank of our matrix. Now let's have a look at an example. Find non-singular matrices P and Q such that normal form of A is achieved in the form of P and Q, where the matrix A is given as this, and hence we have to find out its rank. Now we are going to start solve this problem. Now given A is equals to 1 3 6 minus 1 1 4 5 1 1 5 4 3. Now we will write it in the form of A is equals to IAI. Now if you look at the order of this matrix is 3 cross 4. 3 रोज है हमारे पास यहाँ पे, 4 कॉलम्स है, राइट. सो द ऑर्डर क्या हो गया हमारा, सो ऑर्डर क्या है 3 क्रॉस 4 मैट्रिक्स. तो यहाँ पे ये जो आइडेंटिटी मैट्रिक्स है इसका ऑर्डर क्या होगा 3 क्रॉस 3, और जो हमारी सेकेंड आइडेंटिटी मैट्रिक्स है उसका ऑर्डर क्या होगा 4 क्रॉस 4. सो दैट क्योंकि हमें जो मैट्रिक्स मल्टीप्लिकेशन की कंडीशन है उसको भी हमने क्या करना है सेटिस्फाई करना है कि इस जो फर्स्ट की कॉलम्स है और सेकंड की रोज है वो मैच करनी चाहिए. ऐसे ही द नंबर ऑफ कॉलम्स ऑफ ए शुड मैच विद द नंबर ऑफ रोज ऑफ आई ना, अकॉर्डिंग टू दैट वे. नाउ let's put the values. Now we'll put the value of matrix A here, which is 1 3 6 minus 1 1 4 5 1 1 5 4 3, which is equals to identity matrix of order 3. We will not put the value of A here. We will simply write as A. Now 4 cross 4. 0, 1, 0, 0. Like this. Now what we will do, we will start applying elementary operations on left side as well as on right side. But remember one thing, row operations to be applied on first matrix and column operations to be applied on second. तो हमने करना क्या है, यहाँ पे रो ऑपरेशंस लगाएंगे और कॉलम ऑपरेशंस भी लगाएंगे सो दैट हम इसको किस फॉर्म में बना पाएँ. इसको हमने बनाना है इस नॉर्मल फॉर्म में. बट इस चीज़ का भी ध्यान रखना है, जब रो ऑपरेशंस लगाएंगे तो सिर्फ इस फर्स्ट मैट्रिक्स के ऊपर लगाएंगे और जब राइट साइड में, और जब कॉलम ऑपरेशंस लगाएंगे तो सिर्फ इस सेकेंड मैट्रिक्स के ऊपर लगाएंगे. नाउ लेट्स कंटिन्यू to the other part. Now we will start applying the operations. So my first target is to change these two entries to 0. And let's apply the operation on R2 as R2 minus R1 and on R3 R3 minus R1. Now the matrix A is having entries 1 3 6 minus 1. On operating R2 minus R1 we get 0 1 minus 1 2 0 2 minus 2 4, which is further equals to, now we will apply these two operations on first identity matrix as well. So we get plus 1 0 minus 1 0 1 A, and the matrix Q, that is the matrix which was the second identity matrix, this will remain like that. No changes will be done in that matrix, क्योंकि हमने अभी तक कोई कॉलम ऑपरेशन नहीं लगाया तो ये वाली मैट्रिक्स में हम कोई भी चेंजेस नहीं करेंगे. ये जो हमारी सेकेंड मैट्रिक्स थी. Now the next target is to convert this 2 to 0. For that we will apply the operation in R3 as R3 minus 2R1, which gives us 1 3 6 minus 1 0 1 minus 1 2. Now applying this operation we will get the last row as complete 0, and applying the same operation on right side we get R3 minus 2R1 1 minus 2 1. Again the second matrix will still remain same until or unless we apply the column operations like this. Now we have achieved zeros in the lower part of this matrix. Now our next target is to convert the other remaining elements to the zeros. Now for that the first step is to convert these three elements to zeros. So what we will apply here, on column 3 we will apply the operation, on column 2 we will apply the operation C2 minus 3C1. Along with that, we will apply on C3 as well, C3 minus 6C1, also on C4 as C4 plus C1. Now we will apply these three operations on left hand side as well as on this second identity matrix, but the first matrix now will remain unchanged. अब इसके ऊपर कोई ऑपरेशन नहीं लगेगा, जो भी ऑपरेशंस हमने लगाने हैं इस सेकंड मैट्रिक्स के ऊपर लगाने हैं या फिर लेफ्ट साइड में लगाएंगे हम. लेट्स कंटिन्यू. सो we get, and this matrix will remain same like this only, and applying the operations here now. C2 minus 3C1, so it's minus 3, then C3 minus 6C1, and then on C4, C4 plus C1. We are here. Now our next step is to convert these two entries to 0. For that, the operation is going to be on C3 as C3 plus C2 by using this entry na, and on C4 as C4 minus 2C1. So after applying the operations, we get zeros here, and again don't apply anything on this first matrix. We will apply the operations on second one because they are column operations. So since the operation is on C3 and C4, the first two will still remain same. Now on C3 it's C3 plus C2, which gives minus 9, 1, 1, 0. C4 minus 2C1. Next is C4 minus 2C1. So 2 and 6, 7. Then minus 2, 0 and 1. Now as we can see, in the left hand side we have achieved the desired normal form. This is identity matrix of order 2. We can write it like this, I2, and the remaining elements are zeros, and the first matrix can be renamed as P. A will still remain same, and the second transformed matrix can be renamed as Q, which is the desired normal form. And according to the result, the rank of our given matrix is going to be 2, which is given by I2. This was all about to find a rank of a matrix using the concept of normal form. Let me know if you have any doubts so that we can discuss them in our next video. Thank you.